Cloudtop Cruise is a course in Mario Kart 8 Deluxe that has this amazing lightning section that I just can't ignore. Look at this place! The aesthetic, the lighting, I absolutely love it! But then I started thinking. A dangerous pastime, I know. What's the story behind this thunderstorm? Is it even a real thunderstorm, given how many other weather conditions are fake in video games? If it is, what type of thunderstorm would it even be? Let's dive in and find out. Now, if weather were easy, we'd just say it's a thunderstorm and move on, given what we see. But this is a video game, so it's never quite that easy. Taking what we know about the weather here on Earth, we're going to try and apply this logic to the gaming world. There are several different types of thunderstorms that can occur on Earth, so how are we going to narrow this down? To do this, let's start at the very beginning, with thunderstorm formation. It starts simply enough, requiring only 3 ingredients. The first thing we need is moisture, typically coming from a water source. The second is instability, which is when the atmospheric conditions are considered ripe for thunderstorms, usually involving warm air near the surface and colder air aloft. On its own, instability would do absolutely nothing, not without a bit of a push to force the air upward. Said push is our third ingredient, known as atmospheric lift. Given that we have a thunderstorm at all, at bare minimum, we have the 3 ingredients, but what type of thunderstorm this is depends on the strength of those 3 things. To give you an idea of how this works, let's see what sort of thunderstorm develops in cases of increased moisture, increased instability, and increased lift. Say during thunderstorm development there's an excessive amount of moisture. If this is the case, you're looking at a thunderstorm that has increased condensation, resulting in a greater number of clouds and precipitation, as well as greater heat release. Some examples of this are single-cell and multi-cell thunderstorms, which are exactly what they sound like. They're thunderstorms with one main cell or multiple cells. Now, I can't say the same thing happens if a thunderstorm has greater instability. In that scenario, a thunderstorm will have stronger updrafts. If you're wondering what an updraft is, this is quite literally an air current that moves upwards in the atmosphere. It's usually warm and moist for the purposes of thunderstorm development. This sort of thing will cause a thunderstorm to increase in size vertically and increase the chance of hail to occur along the system. One good example of this is a supercell thunderstorm, which is a long-lived and highly organized storm feeding off of an updraft that is tilted and rotating a lot of the time. So you'd think that increased lift, being the push that makes instability react in the first place, would result in a similar thunderstorm type, but it doesn't. If the lifting mechanism is stronger, this often results in greater wind speeds, which can result in a literal line of thunderstorms traversing over an area. An example of this is a squall line, a group of storms arranged in a line, often accompanied by high winds and heavy rain in areas. Given this, I think we can reasonably determine that instability, moisture, and lift will create different kinds of thunderstorms if they have different degrees of intensity. Let's use this to determine if this thunderstorm in Cloudtop Cruise is even real by determining if it aligns with a type of thunderstorm we see on Earth. There's just one problem. They're all so different. How are we going to possibly make that determination? Since we're so high up in the sky, determining this might just be a little difficult. We can't exactly see what's happening on the surface. The game doesn't allow for that inherently, and I'm not breaking my copy of the game to find out. Instead, we're going to try and work with what we have. I have a potential solution though. Remember where we are when we're launched into the supposed thunderstorm? That's right, we're in the supposed thunderstorm. We can see flashes of lightning going from cloud to cloud in this place. Ironically, that's the most common form of lightning that can occur in nature. Go Nintendo for doing something right there. Though, looking at inside of this cloud, despite it being pretty dark, there's oddly not much in here. Okay, well, there's a ramp and some boost panels, but I'm talking about the weather in the clouds. There's something streaking by, probably rain, but is that even realistic? Why would we have rain in a thunderstorm cloud? Surely we wouldn't, right? What if I told you that we can, and we do? Before you head to your keyboards and tell me I'm wrong, hear me out here. In a thunderstorm cloud, there can be different types of precipitation. Of course, there's water vapor, which is invisible to our eyes alone, as you might expect, but there are other things we can find in a cloud too that can help us figure out what kind of thunderstorm this is. Every single thunderstorm has the following: water vapor, cloud droplets, raindrops, ice crystals, and grapple. Okay, I just rattled off a list, and you probably don't know what at least 2 of those things are. Let's define them. Cloud droplets are liquid water droplets, like water vapor itself, but lighter. So they tend to stick around in the atmosphere. These are what clouds are made of. Get enough of them together and you'll be able to see a cloud. Beautiful thing. Ice crystals are frozen water vapor, which is formed when the water vapor ascends high enough into the storm to the point where the atmosphere is below freezing. Graupel is a soft ice pellet that forms from super cooled water droplets. It's smaller than hail and tends to be softer, so if it hits the ground, it's not going to hurt nearly as much as getting hit by a hailstone. Though it'll still hurt if it's moving at fast enough speeds. I don't recommend getting hit by hail or graupel. Kinda hurts. Not speaking from experience or anything, nope, not at all. So in the course itself, the only thing that would be visible to our eyes are raindrops, since they're big enough for the human eye to detect. That's likely what these streaks are in the cloud, because literally everything else is invisible to our eyes at their current sizes. The only reason we know they're there is due to the other things we can see. We're in a collection of cloud droplets, which all come together to form a cloud, so we know there have to be some, else you wouldn't be able to see the cloud. Water vapor must exist, or else a thunderstorm couldn't form to begin with. As for ice crystals and graupel, we know they exist because lightning forms in here. These crystals and graupel pellets collide, exchanging electric charges, causing charge separation. When this happens, our ice crystals and graupel pellets can be positive and negatively charged. If we have these opposite charges occurring, lightning can form between them. After all, opposites do attract. This leads me to believe that we're indeed dealing with a real thunderstorm. Thank goodness, because I really have no idea what else this could be otherwise. Although I love how I can determine that this is a thunderstorm before figuring out what type of thunderstorm it is. Go me. Anyways, the only problem I can see now is determining what type of thunderstorm it would be. Given that it's such a small section of the course, I can see 3 possible answers. This could be a single-cell thunderstorm, a multi-cell thunderstorm, or a supercell. I want to figure this out, so I'll go in order from smallest to largest. Single-cell thunderstorms tend to be small, brief, and generally weak. They form, then end within an hour, usually. I find the Cloudtop Cruise thunderstorm less likely to be this, since there seem to be multiple clouds in this layer. And by multiple, I mean more than 2. I think that this storm could easily form and dissipate in a short amount of time, for sure, but it doesn't seem to be impacting many other clouds, just this one section. However, the fact that there seem to be numerous clouds ends this answer before it gets too far. A multi-cell thunderstorm is a lot more common. It has similar characteristics to a single cell, usually lasting for 30 to 60 minutes. This is what most people think of when they see a thunderstorm as it extends across the sky. This one has great potential in my mind. It extends for a bit of a distance and has lightning going from cloud to cloud. It's a contender for sure. A supercell thunderstorm has some potential as well, given that the thunderstorms here could last longer than I think they do. It's possible that the storm here could last an hour or longer, but the real test to determine if this thunderstorm would be a supercell or a multi-cell is one final component of thunderstorms which either lets them keep running rampant or stop them in their tracks. Pretty much every thunderstorm has this one component, so I like to call it the secret 4th ingredient in thunderstorm formation. This ingredient appears due to how the atmosphere naturally handles itself. This secret 4th ingredient is known as wind shear. If you've never heard of this term before, don't worry, it's not too complicated. Wind shear is the change in wind speed and direction as we ascend in the atmosphere. The wind does this naturally already, changing speed and direction as we go from ground level to further up. The question is usually how much. For a thunderstorm to last as long as a supercell does, we need relatively strong wind shear. Specifically, we need the wind speed to increase as we go up in the atmosphere, and the wind direction veers, or moves clockwise with height if you're in the northern hemisphere. If you're in the southern hemisphere, it works differently for various reasons I will not get into here. There's just one problem. We can't look at how the wind changes with height. We have no way to measure such a thing in this game. In the real world, we have several options, but in video games, I can't exactly launch a weather balloon. That's not how that works. We're not out of options yet, though. There is one thing that can form in supercells that doesn't form in most others. A supercell thunderstorm, to be considered a supercell, either must have 50-knot winds or 1-inch diameter hail. While we can't see the wind, last I checked it's pretty invisible to me, we can see hail. 1-inch diameter hail is pretty noticeable, I won't lie. That's not exactly in the vicinity of this thunderstorm. I don't see anything white falling in and out of the cloud. Given all of this, I'm led to believe that this is a multi-cell thunderstorm. The amount of lightning in here is reasonable for such a storm type, not to mention it checks all the other boxes. Okay, that was complex. but I'm glad I was able to sort this out using the power of deductive reasoning. Please keep in mind, though, I do this for fun. My word is not the end-all be-all to every weather question. I just like theorizing and having some fun. Thank you all so much for watching. If you enjoyed the video and want to see me talk about the weather in video games, be sure to subscribe. I have more on the docket that I can't wait to share with you. I will see you all in the next one. Have a good day, everybody.